have to hold it this way. Yeah. No. Thank you. Right. Thank you, everybody, for coming here. Thanks for your time. I'm happy to be here to present the tool called Polar Espresso, which actually pulls shots of Cloud Live Response and advanced analysis. We're going to get back to the name a bit after. My name is Ukshini. I am a detection engineer at P0LR Security, a US-based company focused on universal identity detection, protection, and uncovering and finding evil across all integrations on cloud. I am from Kosovo. It is a country in Europe, in Balkans. There's a picture of me drinking coffee or espresso with the Yeti character. So that's kind of the name that the tool has. It's because I like espressos a lot, drinking them, and it kind of makes sense for the tool and its purpose. So we're gonna go ahead and dive into the agenda. We're gonna go and have an introduction about the topic that we are about to speak today. We will dive into the problem, which actually is different vendors, different logs, different hunting, and definitely different IOCs, indicators of compromise, which is a huge problem nowadays on all cloud environments, on threat hunting, on every kind of defensive mechanism, or however we choose to approach it. Different logs and vendors really make a huge problem in that. We're going to go ahead and talk about the solution, which clearly is the tool I'm about to present today, the Polar Espresso. And in the end, we're going to see a tool demo, which will dive into the different aspects of the tool, what it does, and all the features it currently has. So let's begin with threat actors bounty, which is different logging, or we can also call them attackers, or we can also call them adversaries. We can call them however we want, but in essence they are all the same thing. It's actually a bad person doing bad things, or a person with good tech skills using them in a bad way, which is kind of similar to cloud logging, which nowadays it started shifting its name to vendor logging, which is a really big problem, and it's the topic of today on how we are going to treat that in order to make it easier for defenders to go through different cloud logs, perform all the threat hunting, incident response, all other processes that they need, documentations, and all of that, and also how it affects detection engineering. So, cloud logging, as we know, is a crucial part. It's our eyes on cloud infrastructures. It's our visibility on what's happening on cloud infrastructures, let it be AWS, GCP, Azure, Okta, whatever cloud integration that we use. Logging is the most crucial part, and it's the only thing or only chance that we have to have visibility across our identities in environments, and it's the only chance to catch an attacker, find malicious activity performed by an identity. Even if it's not an attacker, it can be an insider performing espionage for other companies or whatever other activity it might have going on. So log diversity is pretty much a huge problem nowadays, since we have all those cloud vendors, as I mentioned before, and each and every one of them has their own way of logging things. Now, by logging things, I mean having different field names and different approaches to how they choose to have visibility on actions and activity on cloud. And that usually affects threat hunting and incident response, which is an important part for, every company that uses cloud resources, since going threat hunting and incident response and also detection engineering, which is creating detections for our cloud infrastructure, trying to catch malicious activity, trying to find malicious patterns, dealing with log diversity is a big problem. And we can say long live the logs, since we really need them, but when it comes to different logs, we definitely don't want to long live different logs. We want that gone as soon as possible, since that's a really problematic area. So yeah. Now for the main topic, we're going to go ahead and present the real problem. So as we all know, logs speak different languages, and most of the time identity is lost in translation, or same identity across all integrations, but it's different in each integration by the way it is presented. And from that we have fragmented fields, we have also fragmented defenders, and that's the way that we present the same identity, we present the same IP address, we present the same user agent, the action that is being performed on cloud environments. It is different on every one of those. And we also have another topic, which is the value of the field names, which is also different on every cloud vendor. But that's kind of another thing to talk about, and there are some kind of solutions to normalize a few things, but the main thing is the field names. So the field names are something that represent, let's say, the action or the IP address across different cloud integrations, and that's the problem here, which is different in every of those integrations. So by having the different fields and different kind of referring way to each of them, affects and brings us a longer investigation time, where we have to separately analyze identity on GCP, then we have to separately investigate or analyze the identity on AWS, we have to separately investigate the identity on Okta, on GitHub, or whatever else we use, and automatically we have to perform numerous translations between all those cloud vendors, which definitely brings us a longer investigation time. Now we have to have a different approach for compromised identities. We have query fatigue use, depending on what platforms we use to extract the logs or go through logs and find malicious patterns. We have to kind of reinvent the wheel for every log source, and we also have to build different detections for let's say if we want to investigate an identity or we want to track an IP address and have an IOC for that, we have to build different detections or different IOCs for every kind of cloud platform. It's kind of similar like driving threat hunting and incident response with a manual gear. So you have to switch it between Azure, AWS, Okta, GitHub, or whatever. The most important things is sometimes we have to switch in reverse, which is the worst thing. So every log source feels like a separate road. It has a slower scoping, slower containment, definitely a slower response, and you have to definitely press the clutch for every log source. Now detecting the behavior, not the log format, is what we kind of want to achieve by this tool, which is a huge problem. Because one rule to rule them all is still pretty difficult, because you can't do that yet, since all of those differences between cloud vendors, and again logs speak different languages. Attackers most of the time hope that defenders get lost in translation, since we have multiple cases where an attacker compromises an identity in a specific cloud platform, and after that, they manage to get access, let's say, in a crucial environment. From that, they try to perform lateral movement across other cloud integrations. They try to gain more access. And by doing that, when multiple cloud sources are affected, we definitely know that it's going to be a huge problem to track that identity's activity across all those platforms, having in consideration that each logging is different and multiple detections often tend to fail since there are differences, and not only differences, but we also have common updates which affect the fields that detections are built in, and numerous detections are repetitive across integrations. That means that, for example, if we only want to have a detection on an IP address or on a user agent, let's say we want to only put a detection for a specific IP address that we know to be malicious, and we want to have visibility on that IP address on AWS, on GCP, on GitHub, Okta, or whatever. We have to do that separately for all those platforms, since none of them have the same field names. So we have to create different detections, even if it is just for one single IP address, or even if it is for an identity. We have to go through all those logs, try to analyze them, what we want to get from them, and then go ahead and create the needed detections. This is kind of like also vendor-bound detections, since you have to adapt the vendor to build detections. So it's not like only cloud detections, but it's more shifting to the vendor-bound detections. So yeah, now the problem isn't the lack of data, is that the defenders are forced to chase vendor-specific field names on their hunts, incident response, and detections instead of attacker behaviors. So we have logs and data across all cloud integrations. I mean, in the most part, because sometimes there are some cloud platforms that require you to pay in order to get logs or visibility on your infrastructure. But for the most part, you get logs for free, hopefully. But the problem here is that we can directly shift into the attacking or attacker behaviors or finding malicious activity, but we have to kind of switch our focus to analyzing and translating logs and stuff like that. So yeah, cloud logs, definitely a no. It's AWS logs, it's Microsoft logs, it's Google Cloud logs, and that's what we are going to see now. So you probably have heard about event name, which is the main field on logs that belong to AWS, which shows the action that has been performed on a service or whatever, is the main part here. For Azure, we have it operation name.value. For GCP, we have product payload.method name. For GitHub, we have it action simply. For Okta, we have it event type, and all these others. As you can see, for IP address, AWS calls it source IP address. Azure calls it client IP address. GCP goes on its own again, and we have to access a bunch of field or objects such as product payload, request metadata, and caller IP. Then we go to the GitHub, where gladly they chose it to go the simple way with actor IP. Then we have Okta, they have IP address, makes sense. Then we have the identity part, where AWS calls it principal ID, Azure calls it caller. We have GCP again, which is product payload authentication and info.principal email. Then we have GitHub, actor, and Okta alternate ID. So this is the problem we are talking about, since for the same thing, let's say for the IP address, we have all these kind of different approaches from every cloud vendor, which is kind of unnecessary, and it makes the work harder for threat hunters or detection engineers, whatever it is. It makes it pretty difficult because, as I mentioned before, if you want to perform a threat hunting or you want to analyze one identity's activity, let's say you use Splunk or KQL from Microsoft, you have to access these fields differently for each integration. Even though you want to just get a visibility over your identity, you first have to understand how AWS calls the IP address field or the principal ID field. You have to understand how GCP calls and how you can access that, since there are three different things: the product payload, authentication info, principal email. Now some things make sense because they want to differentiate and separate logs into different objects, but for the defender perspective, it kind of makes it very messy, since you have to learn and shift between all those things constantly as you go through threat hunting or other stuff. So yeah, it's same but different, but it's still the same. So here we have a comparison between AWS and GCP logs, where we can see for the identity part, AWS calls it principal ID and ARN. Both of them represent the identity in different ways. And from the GCP side, we have the principal email and the principal subject. Now on both sides, it's talking about identity, but it's different in both sides. Now we have the event name, where I took an example, just create role. On both sides, we have event name and we have method name. And as you can see, method name here is part of product payload, which is the main object on top. So every time you want to access method name, you have to firstly access the product payload. The same goes for the IP address, where you have to firstly access the product payload, the request metadata, and then go to the caller IP. And we also have the user agent, where we kind of do the same over there as well. So yeah, this is just another part of GCP logs, which is slightly longer than AWS. Now for investigating on GCP, we have multiple layers to critical fields, as I mentioned before, and we have overloaded queries. Now this is only a small example on how you would access some fields over there, where you can see that only to have a visibility using KQL for method name, which is the main field name, for service name, for principal, for caller IP, for user agent. You have to perform all those normalizations manually, and you have to repeat this for all other integrations. Now this is just the beginning or the starting point to investigate an identity if you want, or you are suspicious that there is malicious activity going on. Now this is the first or the starting point, let's say here, where you want to see that identity's activity. And in order to do that, you have to firstly normalize all these fields and you have to access them. Now, if that identity is across different cloud platforms, this is going to be a problem, since you won't have a unified place to see all those logs and data regarding that identity. And you can do that automatically because you have to shift from GCP to AWS and go through their logs to understand what are the field names, what are they called, and how you can access them from there. Then you have to do the same for Okta, and you kind of hope it will be easier for GitHub, and you do the same repeatedly again and again for all integrations. And as soon as you want to create detections, it's going to be a problem as well, since I mean, you cannot create detections all the time like universal detections for all cloud platforms, but definitely there are plenty of detections that can be universal. For example, we can take here the, let's say, principal email. You have the identity you are suspicious of. You think like he's performing espionage or he has been compromised, and you want to make sure to follow that activity. You want to have a detection for that identity across all cloud platforms, because you definitely don't want to investigate him only on GCP. So in order to do that, you have to perform the same detection for every cloud integration. You have to go and perform all those normalizations. You have to go and create all those like bunch of files for the same thing, for the same IP address, for the same identity, or for any other field. Or let's say user agent, you want to find anywhere the user agent had something to do with Kali Linux, let's say, or anything else. You have to do that. Let's say in the best luck you have 5 files. In the worst case, you can put them all in one file and have a total mess, but otherwise it's not going to be a good approach to have a lot of files, or even in the same file for the same thing across multiple cloud integrations. So the solution here I'm going to present in front of you today is called Polar Espresso, the open source tool that I've been working on. So it's a modular, extensible Python framework, and it currently supports 3 integrations, which is AWS, GCP, and Azure. Planning to add different integrations in the future, which obviously the easiest ones to add were Okta and GitHub. The way of adding integrations goes through logs, so you have to analyze logs again to see which fields you would like to have normalized, and having in consideration all those differences between different cloud vendors sometimes is hard, because you cannot do that because some cloud vendor has some important fields and the other cloud vendor doesn't have those same important fields, so you have to find the common ground over there. What the tool does is normalization. So all these problems that I talked about, the Polar Espresso treats those and normalizes all those key field names. You can also go ahead and create IOCs universally across all your cloud integrations, no matter what it is, as long as it is supported by the tool. You can universally create detections, and you don't have to worry about different logging or different field names. You can also perform threat hunting and analyze identity's activity, since it has unified views, it has detailed views. You can have and analyze an identity by putting IOCs for that identity. So the only thing you need to do in order the tool to work is just feed the tool with logs, whatever logs they are. Of course, as long as the tool supports the integration. So this is the problem that we were just talking about the method name and event name pointing to each other while being the same thing. So you can brew logs, which again goes with the name Espresso. You can choose individual files or select a whole folder containing multiple files, and you don't need to worry if JSON has errors. You just run it. So modularity is key of this tool. As I mentioned before, it supports these 3 integrations, AWS, GCP, and Azure. For the next version, it is planned to support Okta and GitHub as well. And it adapts to custom needs. So when people or defenders want to change the tool to perform investigations based on their needs, they can pretty much change the tool to adapt their needs, and it's pretty easy because it's separated in that way, and its architecture is in that way that you can add more integrations without crashing others, and you can choose all the field names that you want to have visibility on without worrying for making things worse. So since logs speak different languages, normalization gives logs a common language, or like a translator, makes them understand each other. So as we can see here, for the event name on AWS, operation name.value on Azure, and product payload method name on GCP, we went ahead and just called it event action. It kind of makes the most sense of it, since it's an action being performed from an identity. So event action is the most appropriate way to approach that thing. For source IP address, client IP address, product payload, request method, data, caller IP, it's just actor IP. The reason I called it actor IP and not IP address is because on some logs we kind of have different fields where we can see that one field is for the actor that has performed the action, and if you scroll below or down, you can see that there might be another field representing another IP, which sometimes might be the target IP on some integrations, which represents the, let's say, the affected user. For example, in a case where an admin has, let's say, changed or assigned a role to somebody else, we have in logs the actor IP, which is the admin's IP, and then we also have the target's IP address, the one who was affected by that role change or something like that. For principal ID, caller, and let's call it short for GCP, the principal email is just the actor email. And for event source or resource provider or service name, it's just service, what makes more sense, and it's the easiest thing to remember or go around it. So I'm gonna just show a little bit of the main screen of the tool here. I'm also gonna show the demo in a bit. But right here it's separated into 3 sections where in the upper part we have the event list. Down below we have the identity activity analysis, where we have 2 visualization opportunities to see identity's activity, and we also have the IOCs part on the left, where IOCs are shown, IOCs that we create depending on our needs or whatever we choose to do. So the purpose is like normalize once and have the opportunity to investigate every time and everywhere, no matter the cloud provider or cloud vendor. The tool already normalizes those key field names, and all the threat hunter or detection engineer or whoever else has to do is just dive in and investigate without the need to manually go through all those cloud integrations separately and perform all those translations and try to understand every integration's way of logging things. So basically we try to turn vendor chaos into behavioral clarity, where we have the unified main event fields, we have clear field names, you can add or remove field names as needed, so you can use what you need. You don't have to use field names that you don't actually need for your investigation process or purpose. And we also have the IOCs, where you can create custom and simple IOCs based on investigators or detection engineers' needs. So they can be integration specific for AWS, GCP, or Azure now. And they can also be universal, as I mentioned before. If you want to just track an identity or IP address or user agent, you can just go ahead and create a universal detection, which will work across all cloud integrations. They can easily get more advanced. You don't only have to create, let's say, a detection based on the IP address. You can combine different fields, such as IP address, then tie that IP address with an action. So for example, if this, let's say this store IP address has been seen doing this post on Kubernetes, we want to have a detection on that, you can go ahead and do that, combine also all those different field names, so you can get more advanced than that. You can combine, as I said, fields, and sometimes they can be used as kind of queries to quickly pinpoint activity of interest. So if you want to just have an overview of how many times, let's say, an action has been performed on that integration or on that environment, you can go ahead and do those IOCs as well. So this is just a view of the IOCs. When you click into the IOC, you can see here that you have the distinct number of events, users, IPs, actions, and services. You can see how many events are related to this particular IOC, how many users have triggered this IOC, what IP addresses has that user used, and the services affected by that. This can be achieved just by clicking the view details, and it's a pretty good option to have visibility on the IOC and the reasons why it was triggered, and you also have the events tied to that IOC as well. So basically, we try to take an espresso shot and hunt the threat without needing to do all those things manually. As I said before, Polar Espresso enables threat hunting, and it makes it easier, definitely. If you want to perform threat hunting, you can do that with Polar Espresso as long as you have the logs. You just feed the tool with logs and you have it all in there. You can perform compromised identity investigation, and you have multiple visibility options. You have the normalized event list, you have the IOCs, which we just spoke about. You have the identity activity analysis separated into two views. And to go even further, you can also search for all identities, IPs, or actions. And each search provides information about the activity related to that search. Let it be an IP address or an identity, as we can see here as examples. If you search for an identity, you have all those details related only to that identity, which will show you all the IP addresses that that identity has used, all the action that that identity has performed, the services, and the same goes for the IP address. How many users have used that IP address? Where has it been seen? For example, you might have a case where you know that an IP address is malicious and you want to see which users on your company or across your environments have used that IP address. You can just search for it and you'll find out, just as simple as that. We're going to go ahead and dive into the tool demo. Actually, the public release, it's done already. It was released during last conference, and it's available on GitHub. I'm going to show you the link on the end, so we're just going to proceed with the demo here. So we can just access, after we download, we can access the main file here. Just like that. We can brew logs into the tool. We can select the logs that we want to use. So for the investigation, the brew part goes with Espresso, so it kind of makes sense that you want to put logs in there. You can simply select individual files or select a whole folder containing different JSON files from different cloud platforms. Here you can see multiple sessions containing logs inside of them. These sessions can be from any cloud provider, but we'll just go ahead and, in this case, select the whole folder containing all the logs and sessions that we want to analyze. You can see the number of events over there, and this tool is, as I said, separated into three sections: the event list or the detailed view. On the bottom we have the identity activity analysis, and on the left part we have the IOCs, which we also talked about. As we can see, the event list has all the unified field names I just presented to you before. It has the integration, the source file, which is the respective file from where the event is coming from, tied with the integration as well. We have the event action, event time, actor IP, actor email, user agent service, resource, and we also have the IOC hits and the IOCs on the right part. To make it easier, you can just right click and show the IOCs for this event, or you can click into the IOCs and see all the IOCs that are tied to that single event. You can scroll down to have an overview of all the events that we fed the tool with. And then we can group by IP address, where we can see that we have the event count for an IP address, so how many events have been performed by that IP, the first seen and last seen, the unique actors and unique actions by that IP, and also the integrations that are related to the same IP address. Then we have the by user grouping, which kind of shows the similar information just on the user perspective. We have the event count here. We have the first seen and last seen for that user. We have the unique IPs that are related with that user. We have the unique actions that have been performed. Let's say you have 227 events, so only 5 actions were unique, so they were only repeated. And we can also group by action, where we can see the actions performed, how many times they were performed, the first and last scene of those actions, the unique IPs used across those, and the unique actors that performed these particular actions that we just talked about. And we also have the integration part in each view or grouping. So in the bottom here, we have the identity activity timeline, but we'll go ahead and just talk a little bit about the IOCs, where you can see all the IOCs that you have created. Some are just pre-built as examples, but you can also go ahead and create them. You can see here the total number of events related to that IOC, the distinct number of users, IP addresses, actions, and services affected when this IOC was triggered. You can go ahead and click View Details to dive into the details of that indicator of compromise, where you can see the time that it was firstly triggered and the last time that it was triggered. You have the statistical overview on the bottom here, where you have the total number of events. You have the number of users that have triggered this IOCs, which in our case is system anonymous. You have a number of IPs and also the actions. You have a drop. You can scroll on the IP addresses just to see all those that were related to system anonymous, and actions on the other side that have been performed by that identity, and also the events that are related or that triggered this IOC that we created. And the last part is the identity activity analysis, where we have like a timeline showing identity's activity across time that we can also customize. So you can basically just see by the spikes when an identity had higher activity and might have performed, let's say, malicious activity or stuff like that. If it's not constant, then definitely there's something going on. And you can also see their count. The visualizations are pretty straightforward and simple to understand, and just have an overview of what's been going on. So for the next part, we're just going to go ahead and create an IOC just to see an example of how can it be done. So as you can see here, this is the pop-up where you can create IOCs. You have the integration selection, where you can select AWS, GCP, or Azure as per your needs, or you can just go ahead and go with universal and have the detection across all cloud integrations. For the second part, you have the rule name, which you can specify for the reason that you created that IOC, or you can call it detection as well. In this case, we're just going to go ahead and call it system anonymous, doing some cool stuff, or actually not so cool stuff, since system anonymous definitely doesn't do cool stuff. But yeah, you have the description, you have the condition over there where you can specify all your IOC needs. In this case, we have it by default system anonymous, and just in order to help you understand how you can approach the IOC creation, you have it ready. You can just change the field values, or actually the field names if you want to target, let's say, a service or a resource or whatever that is. In this case, we're just going to go ahead and create a detection for system anonymous again, performing IO Kubernetes post, and where the event response code is 0, meaning it was successful, which is a bad thing. most of the time activity from system anonymous gets denied, but if it gets a response code of 0, then that's a bad thing, so we're just going to go ahead and create a detection for that. As soon as the detection is, or the IOC is created, it is automatically saved on the folder. The way to load it is to just reload the IOCs bar over there, and you can see that it showed up. You can see the number of events related to this IOC, users, IPs, and things that we went ahead and talked previously. For the next part, I'm just going to show you the search feature as well, where you can search for identities, IP addresses, and actions. In this case, we're just going to go ahead and search for System Anonymous again, and you can search for any identity across your log, So in this case, we're just going to search for this. You can see all those details. It kind of matches the views for IOCs. It's just that here we are being more specific. We're just searching for an identity. A nice feature to be added on the future here might be the IOCs part as well, just to show the IOCs related to this exact identity. And the same can be done for IP addresses or actions, which we are just going to show ahead now. You only need to type 2 numbers for IP address, and you'll get the recommendations for all IP addresses that match the same pattern across your environments. It shows the same informations and stuff, just a testing IP address, do some testing actions. So you have, again, the active part here, which shows you when it was active from until when, or first seen, last seen, and all the other informations for this IP address. On the bottom, you have all the events tied with this IP address, where you can get more in depth. And you can also do the same for actions. Let's say you have an action of interest. You want to check who performed that action, from what IP addresses that action has been performed. You'll see it right here. You can also see the first and last time that action has been performed, and all the activity breakdown, the users that performed, the number of times one user performed that action, all the IP addresses, services, and also the events here. Oh, yeah. So the aim of this tool was to have this unified platform that you can feed with logs from every cloud vendor, and have all these normalized field names, because normalization is the main aspect of this tool. Normalizing all those field names, having them in one place, since as you can see, if you want to just filter by actor or user or IP, you have integration on the left side and all the main field names on the right side, where you can have them unified, and you don't need to go ahead and perform different translation queries across all cloud vendors and try to learn each one of them the way they log activity. It's sometimes a real pain, since for myself, when I have to create detections, not only for, let's say, an IP address or whatever, as soon as I'm working, let's say, for a detection on GCP, I have to go through the log formats, learn their way of logging stuff, learn how that works, and let's say that takes a time. I finish the detection, now I have to create a detection for AWS. I have to redo it all and over again. I have to learn now the way that AWS logs things, try to analyze the main field names over there and how they work, so I can create an effective and a detection that works constantly. So by having this tool, for me personally, it kind of makes it easier to analyze stuff that I want quickly and effectively. because I can create detections very fast by having that opportunity to do that across all integrations. And not only the field names problem, but sometimes there are also other problems affecting the detection process, which might be the field values, which, let's say, in GCP they constantly change, probably not so often, but they do. They kind of have these version names which you have to make detections that you don't want to miss just because of version change from the GCP side, but that's another topic. The main topic here was the field names, which this tool aimed to normalize. So the three takeovers from here was were the normalized one and once and investigate faster across all logs, build lightweight detection rules that work across vendors, and definitely use Polar Espresso to go through threat hunting, incident response, and quickly create IOCs. Thanks everybody for your time, and definitely if you have any questions, go ahead. Yep. Yep. Excuse me again? I can't hear you well. Uh-huh. Yeah, it can, you can feed the tool with as many logs as you want. It won't fail most of the time. It depends on the detections and IOCs that you also create and want to go through all those logs. The IOCs part is one part of the tool which might take more time to load up, and in case you have a lot of IOCs at the same time, or let's say repetitive IOCs checking for the same thing across, let's say, 5,000 events, that's going to be a bit slower, but it's still going to work, just it's going to be slower, or it might crash from time to time. So the main idea is to try to avoid repetitive IOCs and focus on specific IOCs that you want to have and memorize those, or you can just create a list of IOCs that you have, just so you don't make a new IOC, let's say, for IP address once in GCP. That's why it has the universal part to select and create an IOC for all integrations. So that's not a problem for the most part of the tool. Yep. Okay. Okay. Mm-hmm. Yeah. Yep. So the difference that this makes, or the way that this is different from a lot of SIEM tools or platforms currently in use, as I mentioned before, you have Splunk, you have that other one, and you have a lot of other tools that you can use for going through identities activity. The thing that makes this different is the normalization, which takes all those main field names from every kind of log source, which, for example, Splunk doesn't do that. It doesn't go to the AWS logs, it doesn't go to GCP logs, it doesn't go to Okta logs, it doesn't go to all the vendors and try to come into a common ground to find the thing that matches all of those. So what this does is that it normalizes, and it has, I have put effort in this to try to normalize these key field names, which would make more sense and can be used across IOCs or even just going through the identities activity. This is one thing that makes it different, so you don't have to normalize every time you want to search for a specific thing. You don't have to go through the normalization process over and over again, depending on the platform you want to investigate or find malicious activity, let's say. It has already normalized, and you can just dive into the investigation process or IOC creation without the need to translate logs all over and over again and adapt to different way of logging. Yep.
How is the difference for cloud workloads for speed to get logs?
Excuse me again?
The speed to get logs from different cloud vendors? Has there been differences that you've seen?
Yeah. So the way to get logs from different platforms right now is by having JSON files. So if you have, let's say, multiple sessions or only events that you want to investigate, as long as they are in a JSON file or in multiple JSON files, you can just go ahead and select the whole folder, and it's going to load up all those logs and data that you want to have and investigate and go through them.
Well, I'm saying not the speed of the application, but actually like Google sending the actual.
Yeah. Yeah, so it doesn't have a direct API, so you can connect to Google or connect to AWS or Azure. The thing here is that you will have to have the logs locally. So as long as you have the logs, download them and put them into a JSON format, you can put the logs into the tool. Yeah.
So you support the breaking error, but you also normalize across
Yep.
which are different tactics, generally speaking, than the breaking How are you planning on normalizing the taxonomy for those and the protections that you see upon IOC match?
Yeah. Yeah. So let me just get back to slide here real quick. Just to see the example here for Okta. Okay, so for Okta and GitHub, as you can see, they already have like a more direct and understandable way of logging things and naming field names. As you can see, it calls it actor IP and Okta IP address, actor and alternate ID, action and event type. So it's way easier normalizing Okta and GitHub than it was normalizing AWS, Azure, and GCP. So for that, it's going to be a pretty simple process by just referring to the same thing, just shifting it a bit to match the tool format of naming. But we're going to go ahead and normalize those same field names that are already normalized for the other integrations. And as per the IOC creation, as I mentioned before, you can create different IOCs based on conditions that you want to specify. It doesn't need to be just a simple IOC or only for an IP address or user agent. You can combine the conditions. Let's say you want the identity, you want to have an IP associated with that identity, and you want to only track those two when this specific action has happened. You can also do that. And when you go ahead and add more, let's say, field names, or you want to normalize even more fields, then you can also do that again by also adding more conditions to the IOCs. And for the time of it being triggered, it's pretty simple, as you just refresh and reload, and the IOCs will load up. I mean, the IOCs part will not be affected by adding more field names or integrations. Yeah.
So, I don't know what you said, a lot of that is if I want to, probably AWS or GCP, and say, show me EC2, that's what you normalize it, say, Okta, I'm not classed certified, to do that,
Yeah.
to that, so my IP address and my name might be different algorithms. That's what I'm all so I saw you had that apps there. I had a learned there, I think the tools as well, to say, okay, I'm going to SSL as we use it, but then through my SSL going into AWS, what have you, say, now I'm using apps such as a role text because developer careers developers.
Yeah.
So, but obviously there's some kind of like hash or that kind of way you kind of say like, okay, user came in, it's like almost like a trace log.
Yeah. So you.
Things like that, because like this is kind of what's not so.
Yeah. So you mean like having a part where you can follow the activity of the identity from, let's say, beginning from the SSO through all the cloud other integrations. Yeah, I mean that is a great idea as well, but that is something that actually the company, yeah, it's a lot more, and it's kind of actually like what Permiso does, the company that I work on, where you have the universal identity over there, and you can analyze identity's activity beginning from the SSO or logging in process, MFAs, and through the whole integrations, wherever that identity is performing activities. So you'll have all those related activities shown in a graph format, so you can follow all of that like by using the company's product, which aims to have a universal identity across all cloud platforms and find all the malicious and unveiled threat actors hiding onto the identities patterns. Yeah. Yeah. Yeah, definitely, that makes sense. Okay. Okay. Yeah. Thank you very much. Thank you.